And welcome to a VSA Capital video blog, and delighted today to have the Marketing Director of Ethernity Networks, Brian Clough. Brian, good afternoon to you.
Hi, Andrew. Thank you.
And obviously you're talking to me from Israel, where I don't think your lockdown restrictions are quite as hard as ours, but it's obviously we can't travel and see each other. So it's great that we can do this by video.
Yes.
Now, look, Ethernity, not necessarily everybody has heard of you, and you make FPGA smart NICs, and that all sounds quite complicated. Can you very quickly explain to sort of in layman's terms what it is exactly you do at Ethernity Networks?
Sure. So an FPGA is a programmable chip, very similar to a CPU, a little bit bigger. But the primary difference between them is that CPUs process things sequentially, which is great for computation and controlling applications, but is not so great when it comes to networking and security, where you need to process millions of traffic flows in parallel. FPGAs, as opposed to CPUs, process these things in parallel. So they're optimized for handling the CPU-intensive networking and security functions. And when you take an FPGA and you stick it onto a network interface card, which is a card that is inserted into a server so you can handle data transmission, you gain a lot of efficiency in your network. You use a lot fewer CPU cores, and that saves on space and power. You reduce latency, which is the delay in the data transmission. And latency is an important topic because 5G requires exceptionally low latency to be able to support the target applications within 5G.
Okay, well, we'll come on to 5G in a minute. I mean, so what you're basically saying is that what you're doing is a smart NIC, for want of a better word, is something that's out there and anybody can access, but you're programming onto it additional capability to make should we say, a smarter smart NIC, if that's the right word.
Well, the programming that we have on our FPGA smart NICs is, first of all, because it has an FPGA on it instead of a different type of processor on it, there are efficiencies involved in that, and it's especially optimized for networking. Beyond that, the programming that we have on there tends to be, we have 17 years of experience with telecom related networking, functionality and features. And we've loaded a lot of that onto the FPGA on our smart NICs to create an especially rich, package on there for operators.
Okay, so just a bit of a flavor, because obviously there are other people working with smart NICs. I mean, who else is sort of in your space?
Yeah, there
perhaps
are
names people would know.
Plenty of smart NICs out there. Intel and Mellanox have their own smart NICs, but and some of them use FPGAs and some of them don't. So the primary difference, though, between their smart NICs and our smart NIC is, first of all, again, ours are very much optimized for telecommunications networking, and we are the only ones who have a router directly on the NIC. Part of that has to do with our patents. Our patents are such that they allow us to fit more onto an FPGA than pretty much anybody else can. And that allows us to have a full router on the NIC itself. That's very attractive to operators.
Okay, so, and again, just so I think we're getting a flavor of you're putting this stuff on top of the smart NIC. And obviously you're very heavily used in the telecoms industry. Now, I think you're going to tell me off, but I think of this as edge computing. I think that's a phrase you're not so keen on, but I mean, that's effectively what you're doing with your capabilities, isn't it? Is taking it away from the sort of the blockage in the middle, shall we say, and bringing everything outside so that it can operate much quicker.
Well, that's true, and we are involved in edge computing. When you're dealing with a huge data center, it's real nice if you can save space and reduce power consumption in order to save money, but it's not absolutely critical to the success of the network. But the content providers have moved many of their services to the cloud and then further out toward the edge of the network, closer to the end users, which that by doing that, they reduce the delay in transmission time or the latency. At the edge of the network, space and power are especially valuable resources. Operators need to save on those things as much as possible. So an FPGA SmartNIC such as ours can reduce the need for CPU cores from, let's say, 24 to 36 cores that are required for a pure software-based solution to handle the data forwarding and the security, down to, in our case, we can get it down to only 1 or 2 CPU cores. So the remaining cores can be used to can be allocated to tasks that they were intended to handle, the computation and the management that CPUs are so good at. But even more so, the fact that you're using fewer cores means far fewer servers are required. That's going to save a lot of physical space. It's going to save a lot of power consumption, and therefore it's going to save a lot of money. So at Ethernity, we can save operators up to 80% compared to software-based solutions that run on CPUs.
And this is also why you fit into 5G, because 5G doesn't really exist today, does it? It's more like a sort of 4G plus, because for 5G to work, you're moving so much information that it couldn't do it if you had you'd need so many cores, wouldn't you, to get it all done. By using your product, you free it all up, and actually it allows 5G to happen. Is that correct?
That's absolutely right. So like you said, most of the operators who are currently advertising 5G are actually providing enhanced 4G service that makes use of some of the principles of 5G. But very few operators have actually installed enough of the newly required infrastructure to offer true 5G. So for example, in China, which is far ahead of most of the rest of the world when it comes to preparing for 5G, it's estimated that they're ultimately going to need to install about 10 million new 5G cell towers. And yet they've only installed about 600,000 of those cell towers so far. But the nice thing about 5G is that it's a greenfield technology. It requires new equipment pretty much across the board. And this allows the operators to start considering alternatives to the traditional single vendor closed architecture that they've used in previous generations. So this has led to a new concept, which is called Open RAN, which disaggregates the radio access network, that's the RAN part, and enables the operators to choose the best-in-class solutions for each device or node in their network. Ethernity believes that FPGA SmartNICs are an ideal platform for Open RAN because they offer interoperability, they offer flexibility, they're fully programmable. That means that they're also future-proof, which is to say that unlike the monolithic proprietary hardware that operators have relied on in the past, FPGA SmartNICs can be repurposed or reprogrammed while they're already deployed in the field to handle new protocols or security algorithms as the new technology develops. And that represents a huge savings for operators.
So, on that area, obviously we all know with these towers and everything, the 5G network's been, we had this big issue with Huawei, who, when you talk China, they seem to be the leader. People got uncomfortable with them being in the UK 5G network. Just out of interest, do you have a view on were we correct doing it? And just in removing or tending to remove Huawei from our network? And does this open an opportunity for you at Ethernity to bring in your product and help, the Ericssons and Nokias, whoever take over, to actually create this new network using your capabilities?
So I don't want to get into the politics of the whole Huawei ban. That's a topic that's beyond the scope of this conversation. But
that's even more complicated than the technical conversation we're having. Exactly, so I don't think we should go there.
But from a technical perspective, Huawei was one of these monolithic end-to-end providers that I just discussed. They offered inexpensive, high-performing equipment, which is why they were so popular. But as I mentioned, you sacrifice a lot of flexibility when you go with one of those vendors. You're locked into that vendor because their products tend not to interoperate with the components and devices of other vendors. And you also lose the future proofing. which means that your total cost of ownership goes up. Once equipment from Huawei or Ericsson or Nokia is field deployed, you can't upgrade it without replacing it entirely. That's prohibitively expensive. So there's this unique opportunity for operators to reevaluate how they've been doing things. 5G requires all new equipment, and yet Huawei has been eliminated as a possible vendor in many countries. So some operators are taking the path of least resistance, and they're swapping out Huawei for other monolithic vendors' closed systems. I think BT has chosen to go with Ericsson as an example. But many of the more enlightened operators, such as Dish Network and Vodafone, they're committing to Open RAN, and they're using this as a golden opportunity to seek more open, disaggregated solutions so they can choose best in class. Ethernity is obviously a big proponent of that model for installing 5G networks, and we're ready with multiple top-of-the-line solutions for mass 5G deployment. A good example is the recent licensing contract. There's a $1.5 million licensing contract we recently signed in India. In India right now, there's a lot of momentum toward made in India products because they don't want to have to rely on a single provider like Huawei, or be in a situation where they have committed to a single provider and then be told that they can't use that provider anymore. So we licensed our technology, which will be used in Indian-made Open RAN products, and then we can then market those products globally outside of India.
So, I mean, if you're right. I mean, the size of the potential marketplace for you is just massive because you'd be needed everywhere. How do you get the customers to come to you and say, you've got to move away from this old style stuff to what we do? I mean, and who are your customers? Is it or you just said it's not British Telecom, but is it Vodafone or something like that? How do you get that process going and the momentum going so everyone says, look, we've got to have it?
So we work with telecom operators. We speak to telecom operators on a regular basis. We work with manufacturers, OEMs, and system integrators. And we usually sell to the manufacturers or the system integrators who have relationships to then have those products and solutions get into the operator networks. We then earn our revenues based on each piece that is then deployed. We also have models in which we license out our technology and our know-how to the manufacturers, who pay us an upfront fee and then pay us royalties on any resulting sales thereafter. We've already deployed our technology in over 700,000 systems worldwide. We're connecting over 1 million users already. Not all of that is telecom, by the way. As an example, we've also made deals with tier 1 military companies to supply them with something called an avionics switch, which uses the same networking technology for their planes. But we're especially excited for mass deployment of 5G networks because we're primed with solutions that are optimized to address the specific needs of 5G. We're deep into both lab and field trials of those solutions with both operators and manufacturers already. And we are expecting that 2021 should see the start of such deployments. Our technology has been very well received to this point, and we're very optimistic that 2021 is going to bring a lot of good news.
I mean, different countries and parts of the world are coming out of this at different speeds, should we say. I mean, are China ahead of the rest of the world? Often the US actually strangely lags the rest of the world, I find, in some of these things. Are we in the UK ahead of the world? Where do you expect to see these first orders coming through?
It's interesting because I actually expect to see something called private 5G networks be the very first deployments. These are smaller, more bounded deployments in which you might deploy 5G in a single campus or a single building or even let's say a stadium. And it's, you can see the results much quicker there for true 5G as opposed to the 4G enhanced or 4G evolved that we've seen up until now. But China is deep into their field trials of various parts of their network, and they've already done a lot of the groundwork in terms of installing the necessary equipment. Korea is also one of the leaders in the world when it comes to 5G right now. Europe is a bit behind them. Everybody has started paying close attention to what's going on, and they are making progress. I think 2021 will be a big leap forward. I don't know that you'll necessarily see all of the next generation applications right away. That might only come in another 3 years or maybe even slightly more. But it will start to have much more penetration, and the deployments themselves will definitely start in terms of the actual equipment that's necessary, and that's where we come in 2021, probably toward the second half of 2021, but it definitely will.
And do they have to choose you like at the beginning when they start saying, right, this is what we want? Or can you come in at a later stage when they've started, shall we say, building the network, and they say, look, actually what we're going to do now is improve it and enhance it? Can you come in at a later stage? If it didn't happen in 21, is that game over? Or can we say, actually, it's fine, they're building, and we're going to come in 22 or 23?
So interestingly, I'm going to take you the opposite direction first before I answer that, and say that even better than that, you can actually already deploy our solutions in 4G networks. I mean, it's not just 5G. You can deploy us in 4G, and the big advantage to deploying us in 4G is that not only will we enhance your 4G performance of the network and save you in terms of your power and space and save you money, but by deploying in the 4G network, if you haven't decided to go for a 5G network yet, once you've deployed us there, because the FPGA SmartNIC is programmable, it's already ready for 5G. So you can get an instant 5G upgrade. You can deploy it in your 4G network and get an instant 5G upgrade whenever you're ready to move over. You don't need new equipment in this case because it's compatible for both 4G and 5G. In terms of whether you can deploy later on, sure, of course you can. Obviously, it's better to have to plan this out in advance. You don't want to go and deploy things out in the field that you're then going to replace. We mentioned earlier that's prohibitively expensive. In this case, by deploying a NIC, everybody needs a NIC in a server in order to be able to handle data transmission. Whether it's a conventional NIC or whether it's a smart NIC, it makes sense to go for a smart NIC at this point. And if you're going to go for a smart NIC, in our opinion, you should be going for an FPGA smart NIC. Not only that, if already you're going for an FPGA smart NIC, you should probably consider which FPGA smart NIC has the ability to handle routing directly on the NIC. We're the only ones that can do that. That's a huge advantage.
It does sound that way, but I mean, presumably you're not in a completely uncompetitive marketplace. That there are obviously other people who make these, but maybe just haven't got the right or as good a programming as you. So who would your competition be? I mean, who else is playing in the space that?
So, like I said, there are a number of SmartNIC manufacturers in the market. Some, like Mellanox, NVIDIA, don't use an FPGA, but they're rather using multiple CPU cores directly on the card. Others, like Xilinx and Intel, and some of the smaller companies, do have FPGA SmartNICs. But some of those SmartNICs are just shells with no real programming on them, meaning that they require a partner to provide the intelligence on the card. Then there are SmartNICs that are designed for data centers or large cloud deployments that really aren't competition directly with us. Some of those include programming to address specific sectors like finance or medicine or something like that. Like I said, we've been working in the telecom networking sector for 17 years. Our AceNIC family of SmartNICs is very rich with telecom-specific networking features. But again, the primary difference between our cards and our competition is that our cards have the full router on the FPGA on the card. No one else has that capability, and that is very attractive to operators and manufacturers, especially when it comes to 5G.
So you know, I hate to say it, you're in a pretty unique space, and you almost, it's a case of you getting into the market, but also the market presumably coming to you. I mean, 5G actually getting momentum, which it hasn't really got yet. We talk about it, but it's probably the next big thing. I mean, maybe one final question, which I find intriguing. COVID-19 seems to have accelerated an awful lot of new technologies and capabilities, but it doesn't seem to have accelerated 5G. Have I got that wrong, or is it true? And why hasn't it done that?
Actually, it has in a way, because of the desperate need for additional data transmission as a result of so many people using video technology, people telecommuting. You're definitely seeing a need for a technology that can handle larger throughputs of data in less time with less delay, and that's 5G. So to some degree, it has accelerated the need for 5G. Look, 5G is coming. There's no question that it's coming. It might not have the impact that some operators are promising, but there are going to be more and more deployments over the course of the next year or two. The open RAN market within 4G and 5G has been estimated at, in the tens of billions of dollars. It's a massive opportunity, and we're very happy to be participating in that. So, in terms of the opportunity for us, we had anticipated that this would be coming a year or two earlier. Previously it didn't, but we're now perfectly positioned and ready with our products and solutions for the huge amount of deployments that are coming, for this massive boom that's about to come as a result of 5G. Every operator is eventually going to need to convert over to 5G. Every operator is therefore going to need to swap out their equipment. And whether they choose to do so for Open RAN equipment or not is still a question. Like I said, there are operators that are very much committed to doing so. Even the operators who aren't fully committed are also looking into it as a possibility. They'll probably run trials with Open RAN equipment because everyone kind of realizes that down the road, that's the future. Even the Ericssons and Nokias of the world, who are monolithic, end-to-end providers, even they are opening up their equipment a little bit to allow for Open RAN, because even they recognize that Open RAN is coming.
Well, Brian, I'll tell you what, I mean, there's no question that 5G is coming. These things always take longer than you think. I mean, probably for full 5G, it's probably another 5 years before the whole world has gone that way. I think it's fascinating what you're doing. Clearly, the opportunity is enormous. And it does sound as though you've got the right product at the right time. So it should be happy days for Ethernity Networks from here on in.
Andrew, listen, I can tell you that, we recently put out some numbers that showed that we've had growth of about 400% over H1 of 2020 and over H2 of 2019. VSA's own research estimated that our revenues should increase by about 300% from 2020 to 2021, and about 450% from 2020 to 2022, and then continue to grow along with the market. We recently also announced that we are seeing that nearly 60% of our anticipated 2021 revenue is already covered in licensing contracts, subject, of course, to customer confirmation of order volumes. But and that's before we even sell a single FPGA SmartNIC. As for those SmartNICs, we were recently told by a national Southeast Asian operator that they selected us over a couple of tier one competitors for larger scale field trials. So, with the anticipated revenue and the multiples that are implicit in such a huge market, everyone can do their own calculations of the value that we bring to the table.
No, I think they can, and our research at VSA is on our website, www.vsacapital.com, and it's open to anybody who wants to go and have a look at it. Brian, it's been really good talking to you. I think you have made it much simpler in this conversation, which is great. If anybody listening to this still hasn't quite worked out what it is, please feel free to contact myself, Andrew Monk, or Brian Clough directly at Ethernity Networks. But it was very good to talk to you and very useful to have a bit more of an understanding of FPGA smart NICs and what they do and why they're going to be so important in the future. Brian, thank you very much.
Thank you, Andrew. I appreciate your time.